All right, well, welcome everyone. I think we're going to go ahead and get started here. So I want to welcome everyone to this morning's workshop put on by the Population Dynamics and Health Program here at the University of Michigan Institute for Social Research. My name is Brady West. I'm the director of the Scientific and Technical Core of the Population Dynamics and Health Program, or PDHP. And I'm very happy to have everyone here today. It's been a minute since we had a hybrid format workshop for this particular workshop series. And we're very happy to see people in the room today. Hopefully more people will be joining soon. And I want to give a warm welcome to everybody joining on Zoom this morning. So we're very happy to have you here. Just to get started, we're going to say a couple things about PDHP and opportunities and resources within the Population Dynamics and Health Program. So this program provides resources and basically technical support infrastructure to the Population Studies Center and its affiliates here at the Institute for Social Research. This workshop series is a part of that technical support program. So again, very happy to have everyone here today. This will be recorded today. So after the workshop is over, all the materials and the recording of the workshop will be available via the PDHP website, which you see up here right now. We actually have a YouTube page where we maintain all these workshop recordings. So you can also check out some of the recordings of our prior workshops as well. So PDHP offers this workshop series as a part of its support. We also provide consulting services to affiliates of the Population Studies Center. So if you're interested in becoming an affiliate of PSC and you're not already, please do let us know. We're also available for contract work. So if you have a funded research project and you would like technical support or any other kind of analysis assistance, we're more than happy to discuss a potential contractual arrangement with you to provide those kinds of services. So that's something else that PDHP is happy to offer if you would be interested. You can read more about some of the other opportunities that PDHP offers here at the PDHP website. We also have a small grants program. So if you need small grants for any kind of research infrastructure support, you can check out those opportunities via the small grants link up here at the PDHP website. And in general, you can learn more about the different services that PDHP provides, including some of the people, the faculty, the staff up here at the PDHP website. Okay, so turning to today's workshop, just some logistics. If you're in the room, there's no need to be on Zoom. Okay, so you can just participate live here via Zoom, or not via Zoom, via in person. If you are on Zoom and you have a question or anything else, feel free to enter that question in the chat. Paul Schultz from the STC team, who many of you have heard from in terms of organizing this workshop, he's here today and he's going to be monitoring the chat for questions that might be coming in and communicating them to Robert as they come in. Or you can simply unmute yourself on Zoom and feel free to ask a question. We like to try to keep these informal, where if a question pops up, you don't have to wait for a break or anything. So feel free to just interject if you have questions or anything, and I'm sure Robert would be happy to clarify. So yeah, don't hesitate to send questions via chat or just to unmute yourself if you would like. And same for you in the room here. If you have a question, just raise your hand and we'll be happy to hear from you. There are microphones spread out throughout the room, so you can use the microphone if needed. Okay, so let's turn to today's instructor and workshop. So today's workshop is entitled Creating Web Applications with RShiny. This is a very popular topic right now, especially here at ISR, where a lot of people are exploring the use of this technology. So we're very happy to have Robert Ashmead from The Ohio State University here with us today. Robert is a research scientist at the Ohio Colleges of Medicine Government Resource Center. And they conduct health policy research and provide technical assistance to state health and human services policymakers in Ohio. Robert also works part-time for the U.S. Census Bureau, assisting in the data privacy methodology for the 2020 decennial census. In his spare time, when he's not building RShiny apps, Robert enjoys playing tennis and walking his golden retriever. Very awesome. He received his PhD in biostatistics from The Ohio State University in 2014. So without any further ado, I'm going to go ahead and turn it over to Robert. And thank you again for being here, Robert. We're looking forward to the workshop. So
make sure I get my other. All right. Thank you very much for that introduction. And before we get going today, just a thank you to Paul Schultz and the PDHP program for the invitation to talk here today. Yeah, it's really exciting to be able to share some of this information with everyone. So the other thing I wanted the logistic thing to point out before we get going too much is that if you haven't yet, there is a link to the materials for today in GitHub. And if you want to go ahead and download those, we'll be going through those today. So what is R-Shiny and why might you be interested in using it? So first off, this is an open source package in R designed to create interactive web applications. Kind of the idea behind R-Shiny is that it's code-based, but you don't need to know kind of the more technical languages, HTML, CSS, to use it. So the idea is it's very approachable for people, and especially those of us who are familiar with R. The other great thing about it is kind of in the background, we can use all the great tools that are built into R to do the actual computation and modeling and all these kinds of great things, which I think give it a big advantage over some of the other dashboarding tools out there, which are a little more constrained in terms of the statistical features that you can build into them. Another great thing about this is it's pretty much completely customizable in the sense that you're only limited to the creativity that you have in terms of building in the interesting and new features that you have versus something that, you package dashboard apps, you're constrained by what is the options there. So it was Shiny was originally released in 2012. This is developed by RStudio, which is now Posit, and has recently been extended to be used with Python as well. So if those of you who are Python users, I think it's more in the kind of development phase there. I haven't personally checked it out, but I assume that it works pretty well. And then it gets upgraded quite frequently. So I actually haven't looked at the newest release, but just a few weeks ago, they released the 1.80 version. And I saw it had some great features, but I need to check that out. So what's our plan for today? So the ideal scenario here is that at the end of this workshop, you'll have kind of the basics to be able to get started in your own R-Shiny journey of knowing how the pieces fit together and kind of exploring more. So we're going to talk about what are the basic pieces of building a web app. We're going to walk through those building blocks. We'll do a little bit of extensions, and we'll talk about hosting. We'll talk about some accessibility features. And then lastly, kind of as time allows, we'll kind of go into some of the more advanced features within R-Shiny, some neat interactive tables, plots, and maps. So specifically, kind of wanted to talk about what we won't cover today. So we're going to focus on the R-Shiny stuff because we're somewhat limited, but we're going to use a lot of the other kind of beneath the hood R stuff. So we'll be doing using our own functions. So if that is new to you, I think that's something to follow up with after this. I like to use some of the dplyr verbs, so filtering and mutating. So we'll be using that in the background. We'll be using ggplot2 for some of our graphics. And lastly, if you haven't seen R pipes before, be utilizing that. So if you have questions about that as we go through or what the code is doing, feel free to pause us and we can talk about that a little more specifically. All right, so let's start with the basic pieces of the app. Okay, so the essential pieces of an R-Shiny app are the UI or user interface and the server. The user interface is the part of the code that really controls where things get placed on the screen and what everything looks like. Whereas the server side of thing handles kind of all the computations under the hood. And that's going to be where we're doing most of our processing as well. there are two other kind of optional pieces to an RShiny app. The first is what's called the global file. This is a file, or it can also be a function that gets run every time the app gets started up. So this is a good place. I like to use this to load data or define functions or kind of parameters that I'm going to use later on in the app. And the key thing about this is that it only runs once when you start the app. So it's better for things that only need to be done once, right? So if something is in the app, sometimes it gets done multiple times. And from a computational standpoint, that's not ideal. The other piece, and we won't necessarily go into this very much today, there's a folder you can put in your apps called the www or World Wide Web folder, where you can store things like images and files. This is something that gets, when you host your app, that's actually accessible from the outside. So you do have to be careful that you don't put anything sensitive in there. So if you don't want people to have access to your underlying data or anything like that, you need to be careful that that's not in there. We won't go into that too much today, though. All right, so let's go to our first example. And I actually need to pull this up. So I'm going to start this with RStudio. This is example 1. All right, and so this is the code. So there's 3 pieces that I have in here. Like we said, we're going to have a UI, we're going to have a server, and then the last thing I like to use in my code, I actually like to make these little run files that I can just use this little piece of code to run things. So let's take a look at it first, what it looks like, and then we'll kind of talk about what the pieces are doing a little bit more. So I'm going to switch back to RStudio. So I have open the run example 1 file. The key thing to know when running these files is you need to know about the working directory in R needs to be set so the UI and the server are in the right place. So you can either, like I did, right click and start RStudio in the folder, which automatically sets the working directory. The other thing you can do is right click on the individual file and click set working directory, and that will set it correctly. And then all you should do, assuming you have the Shiny app installed, the Shiny library installed, is run this line of code. All right, and we get a browser here that opens up, and we have a little bit, this is our kind of our hello world application here, and just a slight piece of programmable web app. We can type a message, it's going to show up on the screen. So we can say, hello Ann Arbor, and it's going to show up on the screen. So just a little bit of input and output, and it will kind of happen instantaneously. So let's look a little bit closer at what's happening here in terms of our different pieces of the web app. All right, so we have our UI. This starts with what's called a fluid page. We're going to get a little bit more into that in a little bit. But what I want you to focus on is, all right, we said we have just a text string here that says hello world. We saw that in the app. And then we have an input box, which said type a message. And then we had some output, right? So the UI, so one way that's good to get when you're starting to do this is to kind of compare what you see on the screen with what's in the files of the UI. So these 3 pieces versus, hello world, our input box, and our output box. And then in the server is always going to have this input output kind of function statement. And then you can see we're outputting a message. We'll get into kind of the details of this, but I just want you to notice the pattern of the different pieces, where things are outputting and where things are showing. So this is an example of an application that has the UI and server separately. However, we can also make applications where we kind of put everything in one file. So this is the same exact web app as in example one. However, we put all the code into a single file. There's still the components of the UI, the server, and sort of the global here, but we put them all in one file. So if we said the Shiny library, here we define the UI as a function and the server as a function, and then we run it with this Shiny app function here down below. So we could run that real quickly. I'm going to go to example 2 here. Open this up, make sure I change the working directory. Actually, does it help to make this a little bit bigger?
That's good. That's good.
And we could run this and we get the same app here. All right, so that's just to show that there is kind of 2 ways to set things up with a single app or multiple file apps. So I typically prefer to work with the multiple file apps where we have the UI and the server and global in separate files. I find that, a lot of things I do are kind of like, and more in production, you get a lot of lines of code, and basically anytime you can split code up into smaller chunks to make it more easy to digest and find what you're looking for, I find it really helpful. And sometimes I even break up pieces of the UI and the server into smaller parts just to kind of compartmentalize the different parts of a big application. However, if you're working with like a small application, something test, prototype, and you find it easier to share things with a single file application, you'll see that a lot for some of the kind of examples online for kind of getting started. So just explaining that you may see that in different places. Okay, so let's jump into building our example web applications. So the basic outline that I like to follow, or I like to think about, is the following. So first, what we're going to do is we're going to work with that global file. We're going to load up whatever data set or data sets we're using for the application. Maybe there's some pre-processing that needs to take place. We change variable names or filter or do some sort of pre-processing. We may define some parameters in that global file. Next step is we're going to add input, what I call widgets to the UI. So this is where the user can input different parameters for our web application. The next step is we're going to switch to the server. We're going to combine those user inputs with our data that we loaded in to produce outputs. And then we'll place those outputs back in the UI. And then lastly, we're going to add kind of more layout features and design features to the UI to set things up appropriately. So that's going to be the basic outline that we follow today. Once we do that, you can kind of iterate on the different steps to kind of keep going and keep building with your app. Okay, so we're going to start here. We're going to use a specific data set here as our building block. So this is going to be, we're going to use this California County Health Profiles data set. So let's just take a quick look at this website here. So we're taking this from, I think, the California Department of Health. What this is we're actually going to be working with these 3 files here, the 21, 22, and 23 county health profiles. So there's actually a nice little preview here on their website of what this looks like. So what this is rows of data for different counties and different health indicators. We have things like, so you can see here the county, the health indicator, the year, some denominator information. I don't know if it's going to let me go to the right. Yeah, some numerator information, some rate percentages, some age adjusted rates for us to have better comparisons, some confidence intervals in some of these cases, just a lot of information for the different counties. So kind of the motivation I'm going to be using today is, imagining that, we want to build an app to kind of allow users to explore this data. So this is a very common thing I do in some of my work. A lot of, I have this data set, build a dashboard to display this data. It's a common thing that happens. So we're kind of going to imagine that we have this data set. We want to build something for users to explore it and maybe compare different counties, think about what counties are doing over time in these different dimensions. That kind of a motivation. The other thing I want to point out on this page is they have in this website here, this table that we're using. It is kind of an interactive table. It's got some like sorting capabilities. It's got some searching capabilities. We're actually going to build, this is something called a data table, a JavaScript library that uses. We're going to actually, towards the end of the workshop today, we're going to use the same tool in our RShiny app as our interactive table. So it kind of will come full circle. So we're actually going to directly download this data in R, coming from these download links, just to kind of make it simple. There's code in the app to do this, but just to point out where that is coming from. Okay, so what I'm going to do to start off with is just copy this code. This line of code goes, it's very long. This is the download link, but notice here that you can copy this code from these code chunks to the clipboard. And then I'm going to go over to RStudio, actually. Don't want you. And we'll actually just paste this. Okay. So this is reading the CSV from online. And then you can just see those same variable names that we saw in that table here. So the year, the indicator, we're going to be using these rate percentages and the different county names, but just to give a sense of what's in there. Okay, so our first step here is that we're going to load the data up in our global file. So we're building global.r here. So the first thing we need to do is I'm loading the dplyr library. This is just going to allow us to do some manipulations with the data. The other thing that's good with the global file is to put all your library load statements in here, because those only need to happen once and we don't need to use them kind of further on in the app. As you'll see, we're going to start to get pretty good sizable number of libraries that we're loading in here today, but we're going to start with dplyr. So all I'm doing is reading the 21, 22, and 23 CSVs of our data set from the web. And then I am putting them in a list that has the names 2021, 2022, and 2023 into one object. And then we're going to reference that object in our app. Okay, step 2. So now we want to make some sort of file to allow users to have inputs to the UI. So this is what's going to allow users to interact with our app, to make choices, have input. So all this code is going to belong in the UI. There is a small exception, which we're not going to go into too much today, unless there's a specific question about it, or we want to see an example where if your input selections need to be dynamic, then some of that computation needs to happen in the server. But as a general rule, when your inputs are static, they're going to go in the UI. So an example of that would be something like, I have one input, and that depending on which input you choose for the first thing, it impacts the choices that can be made for the second thing. That's what I mean when I mean dynamic. But when it's just kind of a fixed selections of inputs, all that's going to go in the UI. So let's take a look at our example 3 code for this. So I'm going to the run example3.r file, and I'm going to remember to change the working directory, and then I'm just going to run these lines of code. All right, let me zoom in here a little bit. Okay, so what do we see here? We see a bunch of different inputs that the user can use here. And these are just generic. These are not going to be what we're going to use for our county data app. We have some different things, right? We have a drop-down menu. We have some radio buttons. We have a slider. We have a numeric input, which we can both use these kind of up and down arrows, and as well as enter things in. We have this kind of date calendar range and a single date calendar. Let's see. We have a text box input. This is what we use for that hello world example, and a checkbox input. So the point here is just to kind of show you what different options are here in terms of the possible inputs. And this isn't necessarily an exhaustive list of what the possibilities are, but these are kind of, the starting block for us. So let's take a look at the actual code for some of these things, or how we would put these in the app. Okay, so these are functions that we're going to use in our UI. First of all, what I want you to take away from this is to just kind of like look for the pattern of what's going to be the same and different between these different functions. Personally, I do not have these functions memorized. I could not rattle these off the top of my head. So I think the important part that I take away is just knowing how to use them and knowing what options are available, more so than being able to memorize the different options. So all of these are going to have this input ID. That's going to be really important for us. It's going to identify the user input, and then we're going to use that kind of as a tag later on when we need to reference it. They're all going to have this label, which is going to display on the app in the UI, as well as kind of in the background for some of the HTML, which is used by screen readers, which we'll talk about later as well. The select options, we're going to feed it a list of choices. And we can select one to start with, or we can leave that as blank. And then in this particular case, we can also tell it if we want to allow it to have multiple selections or just one. You can see the radio buttons is pretty similar. Input ID, label, choices, selected. Those are we're going to see that pattern over and over again. Some of the other ones that we had in there, we had a slider and a numeric input. Similar choices here again, right? We have the input ID, we have labels. For the slider, obviously these are numeric, so we can feed it in a min and a max and a starting value. Similar with the numeric input as well. The dates, these functions are going to have the input ID and the label as well as start and end dates and some formatting information. And similar for the text input and checkbox. So input ID, label, and initial values are the key things there. All right, so all these inputs are going to have this input ID argument. The important thing there is they need to be unique names because we're going to reference them later on. It doesn't really matter what the actual text string is. Kind of as a rule of thumb, it's good to use names that you can remember.
We do have a question, actually. Sorry to interrupt you.
Yeah.
The question is, how do you change the order of appearance of the slider/radio/text input buttons on the UI? So that might be something you're going to cover later, but that question came in.
Yeah. So I think that's right on our next slide. We'll talk about how those are ordered and where those are coming from. Good question. Okay, so the input ID arguments, so they need to be unique, and we want to give them, meaningful names, I think is the key thing. The other thing is in the actual UI, these functions, these elements are going to be separated by columns, so commas. So here's our actual UI for our app that we were just running there. All right, so the first thing I have in here, this is kind of a cheater way of doing the global. I'm putting these options, these choices that we're using kind of at the top of the screen. Okay, so in our actual UI, right, I put select input, the different options. I end the function, I put a comma. I have the next thing, radio buttons, comma, slider input, numeric input, date range, date input, same pattern here. You put the element and they need to be separated by commas. So yeah, to answer the question about how we would change the ordering in the appearance, we would just change where these are in our UI. So we do a quick example of that, actually. I'm going to go back to the RStudio. And so in our example 3, if I actually open up the UI here, so if we wanted to put, for example, the checkbox input at the top, I'm going to need to remember to delete this comma here because else it will get mad at me. And I'll paste that here and then add that comma back in. And if I stop my app and then rerun it here, we see my checkbox at the top. So yeah, so the ordering is just going to be determined by where it is in the code.
Question.
Yeah,
Go ahead.
so right now we're defining these default inputs for functions within the UI text. Would it be possible to put them in a separate place and call like my date range input, so we are not like defining them within the UI function?
Oh, I see. So you want like the options to be defined elsewhere?
Yeah, like the select input, like we're putting the ID, etc., within the the fluid page function, instead doing it somewhere else, so we don't have like as the size of the app grows, we don't have a bunch of commas growing.
I see. Yeah. So what I would say is how I usually do this if we get a really big app. So say we get different, and one of the examples we're going to do later today is like different tabs in like a dashboard where you're setting. So what I would do personally usually is put the different pieces of the UI in different files and then break it up kind of logically that way. So if I'm looking for something specifically in one tab or another, I know where to look. Does that make sense? We could also, if you wanted to, define some of these things outside of this, you could. So for example, like this choices, what I would probably do, or some of the inputs here, put those in global in one place to just kind of keep the size of the files down as well. Does that answer the question?
Thank you.
Yeah. Okay. I guess the other thing I want to point out here, I'm going to switch. I added this argument here, this launch browser equals true. So RStudio, which I'm using, has an internal kind of browser that automatically pops up. It doesn't always display things true to what you would see if you were kind of hosting your dashboard, I've noticed. So I'm actually going to tell R to use my external browser to look at things, and it just makes it a little bit nicer. So just pointing that out because we added that to our run app. Okay, great. So let's, a lot of windows here. Okay. So let's go back to our motivating example and let's carry forward some of these ideas of putting in these UI elements. So what we're going to do is we're going to think about, right, we have the different data set with the 3 data sets with the 3 years. So we're going to allow the user to say, do I want to look at the data in 2021 or 2022 or 2023? And then we're going to pick a few outcomes which they can select from to display the data. So what we're going to do is we're going to use that select input. This was the drop-down option. I'm going to call it input ID of year to try to be descriptive. We'll have a label that just says select a year, and we will give it the choices of 2021 through 2023. I guess important thing to point out here, I'm using text numbers, not numeric numbers here. So we just have to be careful when we access this. We'll only let them choose one of them here. And then we're going to do a second select input, another drop-down menu with just the three outcomes for now. Deaths due to all causes, deaths due to cancers, and deaths due to colorectal cancer. So this could be, we're just doing a couple here, but you could imagine a more exhaustive list if you were building this in actual production. And in this case, we'll have a default outcome selected, and we'll only allow the user to pick one of them. So to put this, to see this in action, we'll go back to RStudio. I'm going to stop this and let's look at example 4. And remember, because I will forget to do this probably at some point today, make sure you change the working directory so we don't get an old app. All right, so here we go. Pretty boring to start off with, but we successfully have a selection for the different years and a selection for the different outcomes. So that's all we wanted to start off with. If we look at the other pieces of our app quickly, let's see, global, server, UI, we'll open them all up. You can see in global, all it is that, what we talked about before, we're loading the different data sets from the web itself. The server is empty right now, which is why nothing happens when we select the different inputs. We're going to work on that next. And then our UI as we talked about it on the slide. Any questions there? Yeah.
So when you said like the file name as a global.r, when you run the app, will the app automatically know you have to run the global first? Okay.
So yeah, global, like the global UI and server, those are, I don't know, like special file names that Shiny will always look for to run things. So you can't name it something differently and it will work, but it will always identify the global UI and server in the working directory where you're working. So that's why that's important. Okay. Okay, so another just, useful reference, if you're thinking of those UI inputs, Posit has their own their widgets gallery, and we picked a couple of these, but you can see there's also an action button. There's a file input. There's some other ones here too that you can select from. There's also some additional options in other packages for our Shiny. So one that I actually use myself is this Shiny Widgets package, which just has some additional choices of input selections. In some cases, they're just a little bit nicer visually, or have some interesting features that you can also pick from. One of the ones, we use that selection dropdown. I actually, when we're dealing with multiple selections, I actually like the option from this library more, because it has some nice like clear and select all features, which the regular select multiple doesn't have. So just know that's out there if you're interested. Okay. Pause there for any more questions. Okay, great. All right, so our step 3 that we said was to move to the server. We're going to take those user inputs, combine that with our data to produce some outputs. So the server part of our equation is going to use our data, and anything else we make in global, so we could define some of those parameters we talked about, or I'll often define some functions along with our inputs, and we'll produce those outputs. The values of our inputs are accessed by using the object input, and then whatever our unique input ID with it. So this is where you need to match up the part from the UI and the part from the server, and why it's important to give these meaningful names. Then to create our outputs, we're going to use a function from the render family. So these are going to have names like render plot, render table, render text. And then we're going to assign them to an output object with a different unique name that we're going to reference again, right? So the key thing here is match is going to start to be keeping track of matching up the different names from the different pieces to allow things to work together. You can imagine when you start getting a big app, it starts getting really confusing. So it's really important to kind of to keep track of that all. So examples of these render functions, which you can use, just depends on what you are actually trying to make. So there's one specifically for plots, one specifically for tables, one specifically for text, and one specifically for images. And we'll see, they're all going to work pretty similarly. And we'll give an example here. So back to our motivating example. So to start with, our global and our UI are going to be exactly the same as we last looked at them. Right, we're going to load the data. We have our 2 selection inputs. Right, our big thing to key in on here is the input ID is year, and the input ID is selected outcome. So we need to know those to use those. All right, so our new server code. All right, so the server is always going to start with this function input output. But now the first thing we're going to do, we're going to use a render text. So the first thing I want to do is just kind of read back to the user what their selections are. So what we're going to do is just kind of return, you have selected whatever the input year is and the selected outcome to the user, right? Okay, so the key things here are we're using the render text. And note that this particular function is using both the parentheses and the curly brackets. So you can think of these more as kind of like defining a function more than necessarily calling a function, calling a function. because they kind of define what's going to happen to the inputs. So we need to remember that we need both a parentheses and a curly bracket here for the render text. And then I'm assigning this to output $ text selections. So this text selections is going to be kind of the key name, which we'll use for the outputs.
So we've got a question about debugging. So I don't know, this might be something you're getting to way in the future, but I'll just read the full question. You can decide how to handle it. When you have an error or the dashboard is not working as you'd like it to, how would you recommend debugging? Is there an equivalent to adding a breakpoint, for example? So just, you can address that now if you want, or you can save that for later.
Yeah, debugging is can be challenging in anything, but can be particularly hard in our Shiny. I might ask that we'll come back to that maybe at a later point, but please remind me if I forget. Okay, so we have the output and we have our text selections. The other thing I want to do is we'll make a little table just from the selections of the year and the outcome that the user has selected. So for that, we're going to use a render table statement because we're using a table. So the other thing to note here, I've only made kind of one expression here, this paste function for the output, but within these render statements, we can have lots of line of code. We can do lots of manipulations, and we're just returning one piece of that. So you can do kind of your computations with inside there. So the first step you can see here, I'm going to take our data sets, right? This is actually, if we go back to global, right? This is our list of the 3 data sets that we defined here. So I can use that within the server, and I'm going to select the specific year that's coming from the UI from the user. So this is going to be a single one of our data sets for the given year. And then I'm going to take that single year of data set. I'm going to filter the rows in it to just be those for our selected outcome. So the important thing here, when we defined these choices for our selected outcomes, these were the exact names of certain variables within our data set. And these, you'll have to take my word for it. They were the same across all the 3 years of the data sets, right? So these are exactly some of the names of the variables. So we're going to subset to the rows just with that outcome. And then lastly, this select statement just grabs a subset of the column. So I'm going to grab the publication, the year, the name of the indicator, the county, the numerator total, the denominator total, the rate or percentage, and then the age adjusted rate. And then lastly, I'm just going to return that table. So again, the big piece here is kind of the manipulation of these pieces within the render table using the exact names from our input, and then outputting to a different name, which of objects, which we'll use later. Right. So we could go to example 5 and run that. All right, this isn't going to be super exciting because we haven't actually done our last step. We haven't actually outputted those objects back to the UI. So for now, we're selecting things. We have the code set up to do the pieces in the server, but we're not actually returning them at all. So anticlimactic example there for you. But if you want to, this is going to be the same code as in the slide that we have here.
Another question from the chat, in the chance.
Yeah.
where should we put the codes to install the libraries such as the eFlyer? In the global UI or server, or doesn't it matter? So basically just like, you know, in terms of the function calls and that kind of stuff. I don't know, maybe you covered that a little bit, but go ahead.
Yeah, so to actually install the packages you need, you can do, I would recommend just doing that outside. So those are things you only need to do once for the entire system. So once you install them, you can kind of do that manually. Those don't need to belong in any of the files. You just need to update those files, or you can use the actual, there's an interface here if you're newer to RStudio. You can use this interface to install packages as well, or update packages.
Does that apply like to the server as well? I mean, is there anything that needs to live on the web that we'd run into trouble with?
I don't think so. Yeah. So there should be, this should just be outside of the code. So, but the actual, and that's different than installing the packages is different than loading the packages in. So when you would first, you just need to install them once on your system. You know, you may need to update them from time to time, but then actually to like load them into your app, you just need these library calls with the different apps, and that belongs in the global file. Okay, so let's go to the exciting part, which is placing the output in the UI. Okay, so we talked about those different render functions that, you know, were specific to plots, tables, text, images. There's a pair of both render and output functions that we use for each of them that we'll use in the UI. So when we use a render plot to actually show that in the UI, we're going to use this function called plot output. When we use a table, when we use a render table, we're going to use a table output. When we do a text, we'll use text output, and so on and so forth. And then in the output function, we're going to reference, so in plot output or table output, we're going to reference the unique output name we created in the server. So for example, to call, so say we define something called text selections, we'll say text output with the name that we gave it in the server. So there's a lot of names to keep track of between the different pieces, which kind of is what makes this difficult and one of the places where you may need to debug things. Okay, so let's go back to our UI and add some new code in. This part is actually pretty easy. All right, so I'm going to add in these text selections here and then the output table, right? So we do a text output and then a table output. And just to remember where these names came from, text selections and output table, right? This is coming from the name we gave in the output here, text selections, and then output table. All right, and let's run this all to get our exciting output. Oh, I need to stop this. Something didn't work right. You got to stop it. You got to make sure you stop the app first, then set the working directory, and then rerun. All right. Ta-da.
Sorry, we give you a chance to answer another couple of questions.
Okay. Let's walk through this first, and then we'll switch to questions. All right. So, right, we have two things happening here. We have this text string here that just says we've selected 2022 and that's due to all causes. And you can see as we change our inputs, that text selection changes. So that was our first output. The second thing is this big long table we have here, which is a little bit unwieldy, but gives all of the counties in California for the given year and the outcome. And you can see as we change our inputs, we get changes in the outputs here. So success in terms of getting something in the output. All right, questions?
So one is like a technical thing, which there was a request to get a better contrast on your hour console. Someone said they're having trouble picking up the gray background against like your blue text. So, maybe that's something you can handle on the break or whenever you stop. And then the actual question is, well, there's two now. First one goes back to the install libraries. Basically it says, should those be loaded inside UI or before that step? And then this person said, some packages give warnings when loaded in the R source pane or in the QMV file. Yeah, but go ahead, yeah.
Yeah, so to do the package install, if you go back, there's actually this file here, packages install. So you just need to do this once, and this actually happens outside of the RShiny. So you don't need to put this inside of any of the files. You would just need to run this. And then these are some of the things we're going to be using later. But again, let's see. Our example was UI outputs. And then still the only packages I'm loading in here right now is the dplyr package. So yeah, so the package is to install. If you stop the app and do this install, if you haven't done that yet, you just need to do that once during the entire time. And then load it here. You may see some messages from the library because of different versionings of things. Sometimes it gets a little bit upset. You may tell you messages about needing to install the later versions of things, maybe the key piece.
Great. And then, oops, two more. Should we do them now or do you want to wait?
Yeah, go ahead.
First one is, why do we need to keep setting the working directories?
Okay, so we have all these examples in the folders, and the working directory. So the Shiny needs to know which UI and which server to use, and because all of our different examples have a different UI and server and global, we have to tell it which one we use. So we're just setting it to the exact example that we're using for each time. And because we're not reloading kind of RStudio every time we switch to an example, we need to get the working directory right.
Great. And then last one for now. Any tips on how to keep track of the render functions and their paired output functions?
Yeah, so I think if you go to the actual functions, so say, I don't know, RShiny render table. I think it usually gives you both of them in these examples, maybe not. Cable output. Oh yes. Okay. So if you look at the actual like documentation pages for these, you'll see for like render table, it's going to tell you the paired output if you look for the documentation for these. So usually that's just the best source is to look if you're doing a specific type of output to look for the documentation. It will tell you exactly what to do there. Okay. Okay, so we have this app. Let's see where do we have it? But it was kind of ugly, right? So we just have kind of our output splayed all over the screen. We haven't really built in any nice UI or interface. So our last step is to kind of like to clean things up, make it a little nicer looking, add some more design elements. to the UI. Okay, so how do we better? So next step is we'll add some layout and design features. So we'll better organize our UI and then add some, design and layout information. So we've kind of ignored what's at the top of our UI so far. So if we look back at it, it said fluid page. That's kind of like the basic UI for our Shiny. The fluid in this fluid page refers to dynamic sizing of the elements in our UI, depending on your browser. Essentially what it's going to do is it's going to fill the UI elements to your screen. There is also this option called the fixed page, which doesn't resize elements or resizes them only up to a maximum width. That also exists. I've never used it before, and so you can basically completely ignore it. Unless you have a good reason to, but just if you see that in some of the documentation, stick with the fluid page. All right, so layout math. So our layout's gonna work like a grid, defining rows and columns on our page, where the total column width is 12. So everything has to add up to 12. I am not a web designer. I do not know why it's 12, but it is. So what that means is, a half page is going to equal 6, 12 is going to be our whole page, and so on and so forth. Our other basic building blocks are going to be rows and columns. So we're going to use this function called fluid row to build the rows. There's also a fixed row if you were in that fixed page definition. And then we're going to use columns with a given column width. That's going to be those 6 or 12 or whatever to add up to a full page.
Are we constrained to integers here? Can we do decimals in here?
I don't know that I've ever tried decimals. We could try that.
Just curious.
I've never tried that before. I'm going to guess that it could get mad at you because sometimes with the rounding and floating point, I don't know, but we could try it. Okay, so let's add some rows and columns to our working example here. Yeah, just pointing out fluid page here. We're giving it a title. Okay, so now what we're going to do, we're going to start off with a row. And then with what we're going to do is put our different outputs kind of within some columns. I think it's actually going to help. It's easiest to look at the example first and then maybe go back to the code. All right, so yeah, so we're going to make a row with our different inputs and the text output, and then put those in columns. So what we were going to say is 3, 3, 6. So you can see approximately half the screen here for our 2 inputs, and then the other half of the screen for our text outputs. And then below that, we're going to put the table in its own row. So you can see here we had a row, we have our column with 3, and then 3, another column with 3, another column with 6, and then we have our table output in its own fluid row at the bottom. Again, okay, so there's a couple of things to point out here when we start dealing with UIs. A lot of parentheses, a lot of open and closed parentheses, very easy to lose track of where something starts and something ends. So if you're a person that in your code doesn't keep good track of indentation, if you're starting to work with Shiny apps, I would recommend starting to pay more attention to how you're kind of indenting. Sometimes I will also put comments at the end of lines saying like, this closes the fluid row, or things like that, because it's very easy to kind of lose track of where things start and end. And that's a place where, you know, you'll get errors showing up a lot. The other thing is just to remember, we need kind of commas between the different elements, right? So this fluid row ends, our first fluid row ends here. And because we have another, oh, sorry, this is the end of the column. So between the next column, we need a comma. Between our last column, we need a comma. And then at the end of the fluid row, because we have another element here, we need a comma to do that. So that's another place where it's easy to go wrong, is making sure we have commas between things. And it will get mad at us. And maybe this is a good thing to show in terms of debugging. I'm going to open up the UI. I'm just going to delete one of these commas and show how it will. Well, it actually gives me an error here in RStudio, which is nice. How it yells at us. So if I try to run this app, right, it tells us here it's not happy. And actually in the R console here, you'll see it's giving us some information about where it found the error. And then while we're at it, to answer the question of how integers, if it will take decimal points here, let's give this a try, because I'm curious now. Oh, not this. Don't run this code. Okay, well, I guess it does. Decimals are okay. So there we go. Yeah, so
we have a comment from someone here, a helpful tip. This person says the RStudio supports rainbow parentheses to help distinguish between all your various parentheses, so you can switch up the style if you want to.
yeah, so there's some different UIs or different editors that you could use. You know, I actually use VS Code a lot to do, and there's some extensions that help you find the different parentheses in different languages.
Yeah, the color and stuff.
Yeah.
Right? Okay.
So yeah, thanks for that comment. So another thing we could do, there's some other built-in UI options that we have. One of those that I use a lot is called the sidebar layout. So a lot of the apps that I build are kind of in the same kind of theme of like, there's user inputs, and then we have like a table, and we have a plot output. So this sidebar layout does nicely for that kind of a layout. So there's going to be two pieces of it. So there's the sidebar, which is going to be for our inputs, and there's the main panel, which is kind of be for our outputs. So what this looks like, right? So within the fluid page, rather than kind of defining the rows and columns, I'm going to add a sidebar panel function here. And within that, I'm going to have my different selections and then our text output. And then I'm going to close that and add a main panel with our table output. So what that looks like. Go to example 8. Is the following. So the sidebar portion of this gets this nice gray background here with the different pieces, and those are just going down within the size of it. And then the main panel is this portion over here, which gives our table. We kind of run out of room on the right-hand side with our number of columns here, but we can scroll. So that's a nice option that I often use for the apps that I build, kind of some nice UI elements there. All right, what about for multiple views? So one thing that I talked about before is, I mentioned before is, you know, a lot of times if we're building some sort of dashboard which displays, we might have different tabs with different views of the data. And so we can make that with our different UIs. So there's a different option for kind of the top level option in our UI. So instead of fluid page, we can use some different options here. There's some different tabs you can use or different panels within a single page. But what I like to use most of the time is this, what's called this nav bar page, which gives us the option to do multiple pages. So what we're going to do to use that is we're going to replace that fluid page function at the very top with a nav bar page in the UI. And then how you define different tabs or different pages of your app is with the tab panel function. So at the very top level, we have nav bar page. We give that an overall title. I'm going to add a separate page, which is a kind of a landing or a welcome. And I'm just going to add this very small text that says, welcome to the Our Shiny California County Rankings dashboard. And then I'm going to replace and then add our kind of our panel or our page that we've been working on so far. I'm going to call it create a table. And then kind of our sidebar can go in there. So you can kind of stack these items to some degree within each other. So sidebar panel is going to live within our different tab panel.
We have a question about changing the size of the sidebar width. Is there a way to do that?
Yeah, so there's actually, there is an option to do that. Again, they need to add up to 12. Remember yeah, so it's the argument that you would add to the different pieces is a width, and then you say width of 4, a width of 8. So these, again, the sidebar panel plus the main bar panel should add up to 12 within that. So let's look at that example with the different pages with the nav bar page. All right, so we get this nice header at the top of our app that says California County Rankings Dashboard. We have our little message and our welcome, and then we have our create a table interface that we've been working on with the different selections, and our sidebar panel and our main panel here in one page. So this is kind of this nav bar page is what I tend to use a lot for my apps that I use. And we could add, you know, more tabs or more pages here, kind of as we add more content. Again, you know, nav bar page at the top level, and then these tab panels kind of as the second level, then all the content within those goes next. Okay, so those are kind of the basics of the standard Our Shiny layouts. There are some alternatives that have been built for these different UIs. There is there's a library called Shiny Dashboard. And I'll just quickly look at this webpage. This has very kind of predefined portions of the UI. You get this kind of sidebar, and then the main panel. So this is kind of an option if you kind of want very kind of quick and nice looking standard options, but there's some limited customization you can do within that. I think I've also used this if you've done like our Markdown before. You can do this, you can use this outside of Our Shiny itself. There's also this newer Shiny Fluent framework. We're using something kind of the standard Our Shiny uses what's called this Bootstrap web app framework. There's an alternative one called Fluent. And so there's this package that helps you run that. It's pretty, you can run this really quickly. It looks pretty sharp. I haven't personally used it myself. But it does look pretty slick. And so with these different UI options, these different packages, there's going to be some different options that you'll have to use and different functions that you would use with the with those different UIs.
Got a question about multiple tabs
Mhm.
and how we implement that. For just to create multiple tabs, do we simply stack the tab panel code successively?
Yep, exactly. So it's you will define tab panel. If you think about these as levels, so that kind of the first level is that big nav bar page. The second level is each of the tab panels. Then within that is going to be your UI code within the page or the tab. So you would just add wherever this last tab panel ended here, I think it's probably this line, you would just say comma, if tab panel to add another one after that. So you can just stack them in the UI. So this is, we were talking earlier about, can we kind of take some of the code and package it up and make it compartmentalize it a little better. This is a place where you could see maybe having a separate file for some of these things. So it starts to be a lot of code when you add all the options. The last thing we're going to talk about here in terms of the UI is themes. So the theme is what is going to kind of control the look, the feel, the text of everything, the colors, basically everything. But if you were to define a plot in your actual dashboard, so to change the default theme, there are two options. There's a bunch of several pre-built themes that are free and open source and can be accessed via R packages. If you are kind of more an advanced user, you can define your own CSS file, and this would actually go in that www folder that we said we wouldn't talk about, and you can modify or change that. Personally, I have one way you can kind of work around this if you want to try some customization is you can start with one of those pre-built themes. You can find the CSS file for it, and then you can kind of modify your way until you want to kind of change some aspects, but not all the aspects if you don't really know what you're doing, like myself, in terms of those. So in both cases, we need to add a theme argument to the top level UI function. So in either navbar page or fluid page. So this is fairly easy. So all we need to do is go back to our navbar page and add this extra argument here with this theme. And let's try this with our last example. So I'm going to open up the UI for our navbar page. And I'm going to add this line here for shiny themes with what's called the superhero theme. Just to mention this briefly, there's two ways in R of using packages. One is to load them like we're doing in global. So this loads the entire library or the package into the system. The other way is to call them with this colon, and that just calls the one function from the package instead of loading everything into your R session. So from Shiny Themes, we're going to be using this function called Shiny Theme. We'll use the superhero version of the theme. Need to remember to add a comma. And let's take a look at what that looks like. Aha. Okay, so now we have kind of this dark theme here. with the white text boxes. I'm not sure quite which aspect of this refers to superhero, but somebody named it that. We could try other stuff. See which one. Does anyone have one that they want us to try specifically?
Cyborg.
Cyborg. Try Cyborg just by changing the name here and then rerunning. All right, so much darker version there. So those are all the open source ones. Like I said, you can customize your own if you're up for writing some CSS. Okay, so let's review this basic outline before we take a break or take some more questions. Right, so what we've done so far is we've loaded the data in global, and we haven't done any pre-processing, but we could there. We've added those user widgets to the UI in the server. We've taken those inputs, combined them with the data to get the output, placed those outputs in the UI, and then added some additional layout and design features to the UI. So now we have this full working app. The next step might be to kind of iterate, add additional input, go through these steps again to some degree to add more content here. So with the start of our fully functional app, we're going to add some more features next. But we're gonna we'll take some questions, see if there's any questions, and then maybe we'll take a short break for folks.
In the examples of the widgets that were like in the website you put in, like they had an example with like you choose the number of clusters and it does a KNF on the variable. So if we have something like that, but like on a much larger scale, would we have to do the pre-processing and like say if there's 100 different possibilities of a model, running them all, saving in the server, or would it be running in real time and potentially taking like a couple of minutes for the user?
Yeah, so I think you could do it either way. So if you're saying that you had like several, in terms of the options you wanted the user to choose from.
Yeah.
So you could try to predefine it, right? The other way to do it would be to, maybe there's a button or something that runs something in the background of R that returns all the options and then feeds it back to the UI. That's a little more advanced, but that kind of thing is also possible. But I'd say just from like a design point of view, anytime you can pre-specify what the input options are, you should, because that'll save time, right? And so one of kind of the things to think about for design is, the user doesn't like to wait for things to happen. So anytime you can save on that computation, make things quicker, try to and do things ahead of time, I would say to do that ahead of time.
One comment, fantastic presentation. So wanted to say that to you.
Oh, thank you.
And then one question from the chat is, I think you can get to this, of course. How do we share what we see on the browser and our local device with peers and collaborators?
Awesome. So we're going to get to that coming up in terms of the different options for sharing our apps. So that is coming. So we'll add that to the list.
Great. Yeah. Other than that, we're clear on the chat.
Okay, awesome. Let's take about a 15-minute break and come back and restart at 10:40.
Yep, 10:40 local time, 15. That's 14 minutes from now by my clock. So